Alright, welcome to the second video in this series of chassis repair videos. This is the second 19-inch small neck K7000 that I've got. And upon initial inspection, it's very dirty and it's very rusty. Just going over and looking at it right off the bat, the dag wire has been twisted around and is about to break off. This is not good. You can see remnants of wires from the original dag wire that would hook to here and go to the actual monitor frame. So that's missing, so that's been broken off. The resistors are rusted. Doesn't mean they don't work, it's just the outside area is rusted on it. You can see here more evidence of rust here on this one. So there's rusty screws for the flyback. Somebody has removed this, and you can see how the wires have an indentation. They used to be wrapped through this guide, and it's broken, and someone has altered it to at least still hold the wires there. But this is bad. The screws are rusted, the nuts rusted. The HOT is completely original. I've never seen one before ever that said SK, let's get that, SK9487. Never seen that before, but its screws rusted as well. The voltage regulator, and as another oddity, I've never seen a SK9994 before. That's quite odd. Usually it's a ST number, but I mean, if it works, it works. We'll find out. Most of the caps are original. This one's been replaced. This one's been replaced. You can see it's a Nichicon model. Maybe you can't. Sorry for my terrible camera work, but it's a Nichicon. If that's how you pronounce it, that's how I pronounce it. But all these ones that say, what is it? Eltna? Yeah, Elna, E-L-N-A. You can see here E-L-N-A. Those, if you see those are original. Those are what came on the chassis from the factory. So most of these are not replaced. There's one. This one's all damaged up. And you can see it, just to see how dirty it is. It's just filthy here. So I'm not going to worry really about cleaning it up at the moment. Right now I just want to go through and do some testing on all the components. It's quite obvious that you can see how rusty this resistor is here. Oh, it's even loose. Look at that. See how loose that is? Let's look at the back side. Where's the, oh, holy cow. Right here. Look at that. See that? That is a broken pad, a broken trace. If it was still attached, it'd be lifting up on the trace. But it's not. It's completely broken the trace and the pad. So that'll have to be fixed. I can just put a jumper across to the next pad on the trace. But that is, I'm glad I found that. What was I going to show you? Oh, it's obvious that someone had hooked this up to a system without an isolation transformer, because D20 and D21 are different. They're not the same type and rating of the ones that are supposed to be in there. However, I'm sure they'll probably work. But someone has replaced those, and these are the two ones that usually blow between the filter cap and the rest of the power circuit when you hook it up to a non-isolation transformer. So I'm not surprised that these are missing, or I shouldn't say missing, but are incorrect. C58, I thought C58 is supposed to have something there. I could be wrong. Let me look at my other one. No, C58 is unpopulated. I guess I'm used to seeing something there, but yeah, that's just overall general dirty and rusty and wrong components installed and a very odd HOT and a very odd voltage regulator. But everything looks complete. I don't see anything missing. Obviously someone has replaced these 4 pots. I mean, that's the right rating, but it's kind of the wrong one, but I assume that they'll work. So that's been done. But everything looks complete on it. Let's take a look at the back. Except for that resistor that we found there, but the broken trace, it all looks okay. None of the solder pads look bad for the header pins. Those all look alright. No janky hack job on the R103 resistor here. And it looks like somebody has replaced the filter cap or done something with it, because there's no solder on this via, and that's been sucked dry, so I don't know what kind of janky stuff's going on there. Someone's done some work because they put a jumper across this. The yoke pins don't look so bad. The yoke headers don't look so bad on this one. Kind of blobby, but still not too bad. And the flyback, someone's did some messing with that because there's solder missing here. You can see on this pad, someone's done something there. Factory wouldn't do that. It'd be nice and round and all that. So this all looks like it's intact. I don't see anything that's too terrible. So let's get to reflowing and testing. And I'd like to clean this up, but I don't think I'll clean it before we test it. I'm going to do some, assuming that everything tests okay, we're going to fire it up. I'll clean it later, and then I might show it off after it's cleaned on a separate, like on maybe part 3 or 4 or whatever. I'll just bring this in and showcase it before I get back to the topic of whichever one is next in the line. But for now, let's just go ahead and do our testing on the components. None of these other resistors look bad, and that's okay. That's okay. So I guess we will start with the HOT again here. It's this triangle of pins. There's, zoom in here. It's these 3 by the hole. There's 1, 2, 3. It's that triangle there. So again, what we'll have to do is we'll put our meter on diode. And we will go negative lead on the base, which is the top of the triangle. And then we'll go to the emitter and collector. And again, both sides should read 0.5. Well, most likely to be 0.4 or something on this, but you want it to be 0.5. As long as it doesn't do this, that's obviously shorted. So if we go to, I don't know which side is emitter or collector, but we'll go to one side here. Oh, that's good. 0.47. We'll go to the other side, and 0.47. So our HOT is good. Let's do our voltage regulator. Again, pins 1 and 4, which are, let's see, I think pin 1 is actually inboard to the rest of the chassis, and I think pin 4 is outboard there. But if we go negative on pin, it doesn't matter which way you do it, as long as it's not shorted, you're good. So we'll put pin 4 and pin 1. Well, that's kind of an odd reading. It's not shorted, but it should be closer to this reading. Let's get my fingers, there we go. It should be closer to that. So it's not shorted, but that's kind of an odd reading. 0.1. Let's swap these around here. That's odd. Well, at least it's not shorted, so we'll see if it works. Let's do our D18, which is the diode for the yoke connection here. Move this in view. So again, D18 is the diode that helps protect the yoke side of things. It is this guy right here, this guy right there, that diode there in front of the yoke connection and this polycap. So let's see, we're going to want to put our negative lead on this side and our positive lead on this one. We're still in diode. Oh, 0.493, so our D18 is good. HOT is good, voltage regulator is good. Let's check our critical safety cap. Again, the critical safety cap is the one that's just this green monstrous polycap right here. Get these out of the way. This green monstrous polycap right there, right behind the flyback. If that's bad, that will most likely cause all kinds of issues. Your fuse will blow and all that. So let's check that. Again, the way it should work is that both sides, it's these two tabs here and these two tabs here, 1, 2, and 3, 4. Of course, this being the same side of the cap, these should ring together like that, correct? So if you get that, that's normal. Same thing on this side. Should be the same thing. Yeah. But now if we go across, catty corner, that's good. Go back this way. And that should read through like a diode. So there we go. So your critical safety cap is good. 0.473. We'll check R103, which again is over here as part of the power circuit. This guy right here. And for some reason, the last chassis was supposed to be 1.5. This one actually says 2.7 ohms. So we'll go to our ohm setting, and we'll touch one lead of the resistor, and the other one you can poke through here and touch the lead, and we got 3.0. So it's within spec, close enough anyway. So that's good. Let's check our diodes. We know that these two have been replaced, so I don't know if the rest of them will be good. Alright. Go back to diode. And we'll check D23 first. Negative, of course, with the stripe, and positive on the other lead. Alright, that one's good. Let's see if I can get this better in frame here so you can see what I'm doing. Okay, D24. Good. D22. Move that out of the way. Good. 21. Good. 20. Good. All right. So those all. So everything in the power supply and everything checks out. So we'll have to just power it up and see what happens. Those are the main components you want to test. If all that checks good, it should power up. And of course, you'll find out after it powers up whether you have problems with resistors or capacitors or whatnot. But all of those components that we just tested are the major ones you want to check. We know that the B+ resistor is good because, again, like I mentioned in the last video, this will tie to pin 1 of your voltage regulator. This will tie to pin 2. So if your voltage regulator reads good, your resistor will read good too. So we can actually go back to ohms here, and it'll probably be, what was it, 148 or whatever it was. So let's check this here. Oh, I was close. Well, not really, I guess, but 193. If we go back to our voltage regulator, 193. So yeah, it's kind of odd. Maybe that's what this resistor reads. I can't tell because it's on the opposite side here. It says 220. I don't know if you can read it in there. Right in there it says 220 ohms. There you go. So yeah, I mean, with all this stuff like this, it should power up. I can't, attest to that, but we'll have to find out. I want to obviously fix that resistor. So it's a good idea to go through here and try and move these, and if they feel secure, then you're kind of good to go. But that's how I found this one's loose. So we'll have to make a solder jumper bridge on that. But everything else looks okay. I don't see anything that would have to be reflowed immediately. Because I think someone's actually gone through, it looks like someone's gone through and reflowed the this video I see here. I believe this is for your vertical, and I believe this is for your video output. I don't know for sure, but there's more than one chip here. I have changed this out in the past. This one's actually a bit rusty as well. The little green jobbies on there, so I'm hoping this will power up. We'll find out. And then I can go ahead and get to the cleaning and show it off later after it's clean. But this is just going to be for troubleshooting and repair if we need to. And you can see leftover remnants of solder crap there. I'll get rid of that. That's definitely a no-no. This is very close to touching the next pad, so we'll kind of bend that out of the way. Yeah, everything else looks okay. I kind of gave it a cursory look over prior to filming, but yeah, so I guess with this being loose, we'll have to fix that. And again, you can actually see from that it's completely broken up. The pad, it would be lifting the trace along with it if it was still connected, but it's not. It's broken. So, kind of done with the meter here. Let me position this just right so we can get an idea of what needs to happen for repair. And all right, get it in frame here. Come on, you bugger. It doesn't like too close, I guess. Nope. I can't get much closer than that, so sorry. But there we go. Okay, that should be sufficient. Alright, so what we'll do is, in lieu of just putting a jumper, we'll just add a bunch of solder to go right to the next pad. So you can see here that this trace follows to this pad here. So let's simply add a bunch of solder here, and we'll see if we can make that bridge. There we go. Yeah, that whole pad is rusted. All the solder just flowed right off the pad to my jumper. You can see the pad is completely gone now. So that thing is rusted. Let me see if I can scrape some of that away. It's probably too far gone. Let's see here, because I don't. This will work. I mean, it's got a strong joint on the lead, and it's touching the. This will be okay, but it just looks bad. The next guy comes along 10 years from now or whatever, and this would like, what the hell did this guy do? So, you know, the ideal situation would be to just put a jumper across there, even probably across all three of these joints for the trace, but. This works just as well. This works just as well. So let's see if I can actually get anything to stick to that again. Hey, all right. There you go. Perfect. Perfect. Sometimes a little scrapey scrape get you good. So, all right. With that being done, I don't think there's anything else that I need to particularly, easy for me to say, go over. Everything looks okay. There's that one joint, I guess, here I could throw a little more on. A little dab will do you on this joint that was missing some. Alright. I don't have my fan. Moved my fan in the other room, so. Alrighty, let's find out what happens here. Hopefully it'll fire up. This is nice and secure now. This one actually has a fuse in it, so that's a promising sign. I don't have a ground lead. I should probably fix this monstrosity, because this will just break off. You know, I'm probably going to do that. Let's do that. Let's clean up this shitty ground here. So let's zoom in here a bit. And let's fix this. This is just a giant mess of crap here. All right. Okay, get rid of all this wire. Alright, that's much better. Okay. So now we take this other wire here that's all globbed up and focus on it. Yeah, this is pretty shiny. And then you can see a solder ball fell right there. That's a no-no. You gotta be cognizant of that. So let's hack this off. Clip. Alright. And we'll give it a little strippy strip. Alright. And we will. I wish this camera would focus better, but so I'm sorry about that. But what we'll do is, just like it used to be, we will put this through the hole, fold it around, that's how it should be. And we'll have to get another wire to act as our dag. How can I do that? Where would I find? Well, I can use this one over here. Let's do that. Let's zoom back out a bit. Set that there for now. Let's grab this one. That'll work. Put this back on there. Oops, a little bit too much. We'll use that side for the dag, and we'll use this side for the neck board. Alright. Here we go. Holler if you hear me. Go. Alright. Let's feed this one through. Bend it around. And magic. Magic. Alright. And we'll get some. This will cooperate here. Which it won't. Let's get some. Oh, he's a rat bastard. We'll get some flux here. There's probably plenty of flux on there already, but I'm going to put some more on there. Throw some flux on here. And we will solder these in place. Oh, I pulled a bit too hard, damn it. Alright. Man, this is just not working out for me. Stay there, because I need two hands. Okay, we'll have to do that, get it in the picture here. We'll see if I can solder this on here. Just flow a bunch in there, and then we'll pull these. Beautiful. Beautiful. And there you have it. That's much better. Nothing to write home about, but much better. Now also, what I plan on doing here is I'm going to add a little bit of flux on this side of the two wires to keep them together. This damn solder roll is going to be the bane of my existence. Stay there, okay. Let's add a little flux to here. As Louis Rossman would say, you can never use enough flux. Alright. And I want to add some solder to this here. Alright. Throw a little on here. Just so they stay together on this side as well. There we go. Alright. Now, with that taken care of, we should be ready to try it. Hopefully it works. So let me get everything set up for testing on the tube, and we'll fire it up. I got to reposition the camera and all that jazz, so cut away here, just like the last one. When I come back, we'll get it hooked up and see what happens. So here we have our test tube, just like last time. And we'll get this all set up. I did notice here that the anode cap here is a bit chewed up along the edge, so this has had a kind of a rough life. But it shouldn't matter, because really the only important part you need is around right here. This area that actually sucks to the back of the tube. This is the area you want to actually have be intact. The edge along here isn't really too bad, so I'm not going to worry too much about that. But let's fire it up here and see what we get. So we'll do our yoke connection, which I guess is broken. I didn't notice that the last time. Okay, this is fighting me here. There we go. Okay, got our yoke hooked up, and I realized the last time I did this I forgot to hook up the degaussing connection, but again, that's not a critical component. Like I say, always count to 5. And we'll hook up the anode here, which may be easier said than done. This one's a bit harder to control than the last one since this one's older. Okay, that's on successfully. Get rid of that strip part. We'll hook up this just for shits and grins. We'll hook up our neck board. Okay. This one has no connector on it, of course, so we'll have to put the wires on. Now everybody, I do want to stop and mention here, this is the white knob flyback. You'll hear all kinds of people say, white knob flyback, ooh, mark of the devil, get rid of it, replace it immediately. And no. Unless it's physically cracked or it's faulty, they should be rather bulletproof. I mean, of all the horror stories I've ever heard of bad white knob flybacks or destroying chassis or whatever, I've never experienced it. So I don't really replace components unless they're faulty. If they're working, leave them alone, don't change them. There's no reason to replace them if they're working. Doing stuff like that, caps are a different story because caps are critical to the size and shape and geometry, and if you have problems, it's always good to change those out because they will wear out. You know, that's a known fact. But the flybacks I don't really worry about unless they actually die, because there's nothing so catastrophic that a faulty flyback will take out that you can't just replace parts on. So I don't really worry about that too much. And you know, we should have inspected the flyback. I didn't think about that till just now, but it looks good. I don't see any cracks on it, so it's good. So we'll hook up our ground that we just installed. Alright, so we'll count to 5 here. Anode, neck, dag ground, yoke, and our video, which we'll hook up in a minute. But anode, neck, yoke, ground is 4. We'll get to 5 here in a moment. But we're all hooked up. Nothing is touching that I can see. Dag ground's out of the way. And even if it did touch, it touched the frame, which it's already jumper to the frame, so that's no big deal. And I guess that's it. So let's turn it around. And we'll hook up our power, which should be tricky here without a connector. I'll have to put my wire nuts on just for safety's sake, which won't be a big deal. They're sitting right here. It's hard to do when they're facing this way. It's the wrong way. Alright, that's good. Oh. And sorry, bear with me here. There we go. Okay. Now, video sync. Okay. So there's our number 5. So we shouldn't have to worry about anything exploding from powering it on unless something is wrong. And that's about it. So let me back up here. Kill the light so we can actually see what's going on. And we'll fire this guy up here. 3, 2, 1. Hey! Oh, that's an odd sound. Oh, but we've got video. Hachi machi! Can I zoom out at all? No, let me push this back a bit. Oh, back was the wrong way. Well, maybe not. Let's There we go. Ooh. Looks like the bottom of our screen's a bit squished. And it's way too blue, and it's that way out of focus. But hey, it works. That's amazing. 2 for 2. As bad a condition as this was, dirty and rusted, and that broken pad. I mean, hey, as you can see, the white knob flyback works just fine. So let's see if we can do some adjustments here. Oh, yeah, it's way too blue. You can see that. This is making a weird noise, a real high-pitched noise. I guess the other one did too, but not as bad as this one. Okay. Yeah, well, let's see if I can get this in frame better. Move this back. There we go. Okay. Raise this up a bit. Sorry for having to move the camera around like this, but I want to get the whole thing in frame. You can see the bottom of the screen there is squished, wrapping over itself. That is a classic symptom of the 50-60 Hertz pot. So the 50-60 Hertz pot is this little guy right here. And what that'll do is, if that's out of adjustment, it'll cause the top of the screen to fold over. It'll squish it, and then it'll fold over on itself. Just like the bottom of the screen here, you can see it's kind of squished. It hasn't started folding over on itself yet, but I want to show you, it looks like the bottom is squished, and that's due to this little guy right there, the 50-60 Hertz pot. I'm going to adjust that, and you can see exactly what happens. Okay. Here you go. See what's happening there? See how it's bringing the bottom up and squishes it? If I turn it, it fixes the issue, and it'll drag it back up to the top half up here if you go too far. But you can see it's collapsing on the bottom. If I adjust that pot, fixes it right about there. Perfect. So that's a little tutorial on that. I should make a video just on its own for that reference, because a lot of people have problems with that. But let's see if we can't make this look good here. Yeah, the colors are way off on this. That's also out of focus. Let me hit the focus real quick. Hey, there we go. Boom. And I want to turn off the light here. Let me turn the light off. But then I'll have to use a secondary source to see what I'm doing. Oh yeah, those colors are way off. Well, like I said in the last video, any adjustments I do on this I'll have to redo all over again on a different tube, because each tube is different depending on the life and whatnot. Looks like the convergence and the purity is kind of off on this. I didn't notice it on the other chassis, but let's do, okay, we will have to turn our blue way down. I'm going to have to turn our green. Ooh, and that's in our red. Why is it still so darn blue? That's so odd. Well, this tube, like I said in the last video, this tube's had a hard life, so let's start with, okay, let me do a little detail here. Let me show you how to properly adjust your brightness settings. So the first thing you do is you turn contrast and brightness all the way down. Completely down, gone, completely. Brightness, contrast, all the way down. Flyback. Turn your flyback up until you see these raster lines. Turn the flyback back down till the raster lines just go away, right about there. Then you adjust your brightness and contrast accordingly after that. Brightness is way too high. There you go. Or contrast was too high. Okay, so I mean, for some reason blue is way overdriven here. I turn that down. Green, red, If I turn the red and green all the way down, it's still way too blue. And turn the fly back down a bit more. Use brightness. No, see, it's still way too blue. That is so odd. Well, I'll blame it on the monitor. I don't think it's the chassis. I think the monitor's just had a rough life. So I'm not going to worry too much about it, but the chassis is working. Yeah, look at that. Holy shit. Blue's all the way down. Yeah, I think this has an issue with the tube, unfortunately. I'll work on it for a few more seconds here, see if I can make it look somewhat better. Yeah, just anything. Blue is completely down right now. Both knobs are all the way down and it's still blue. So I think I have a tube issue. But like I say, this was a hard life tube. Anyway, so I'm just dragging the video out. Well, we're 2 for 2 on this. And that's an awesome thing to have. So it's working. I'll give it a good cleaning. And I'll show it off cleaned afterward. Of course, I'm gonna order all new cap kits for all these monitors. But this series of videos is just gonna be for, like I say, testing and troubleshooting. If anything's broken, we'll fix it and how to do that. Proper monitor adjustments and things like that will be a separate series of videos. There's no reason to do all that. Otherwise, these will be hour-long videos, and they're already kind of long as they are. So yeah, 2 for 2 success. It sucks that I have kind of an issue with the tube here. I was hoping to be able to use this on a game in the future, but I didn't really do much adjusting on the other chassis. It had a better picture than this one, but I don't think this is due to the chassis. I think this is due to the tube being overdriven on the blue. So I'll have to throw a rejuvenator on here, see what I can get. But for the most part, yeah, the purpose of this chassis, or the purpose of this video, this chassis is fixed, or it's working. And we'll have to see how the rest of them turn out. So far, thumbs up, 2 for 2. So thanks for watching and stay tuned for the next one. Well, I said goodbye already, but on the tail end here, about 5 seconds after I cut the video off there at the end, the blue gun decided to snap itself back into working order. So as you can see here, the image is fantastic, glorious. I got everything adjusted properly. It looks perfect. Size, shape, color, all that stuff. So yeah, for some reason the blue color gun inside this tube is wonky, and it's long life, like I say. But I just wanted to show that it actually did. That's how my luck works. That was the whole time I had it on camera, it was messed up, and 5 seconds after I shut the camera off, it decided to zap itself back together into working order. So anyway, yeah, working good. Tube is going out. I'll rejuvenate it, trying to get it to a reliable working order, but you can see here it looks great, and I wanted to throw this on the tail end here just so you can see that it did actually end up working. So yeah, still, again, 2 for 2 success. No more blue there, you can see, and we'll move on to number 3, so stay tuned.